Hi, today we are going to be solving Chemistry 9701, paper 22 of February-March 2017. So question 1, the table shows some information about the elements in the third period. Complete the table to show the maximum oxidation number of each element in the compounds. So you have been given a table of fixed oxidation numbers for sodium, magnesium, and you can simply write them down according to their group numbers. Question number 2. Explain why the atomic radius of elements in the third period decreases from sodium to chlorine. Okay, so from sodium to chlorine, the nuclear charge increases, whereas number of shells and shielding effect remains the same. Because since they are in the same period, the shielding effect would be the same due to the same number of shells, and due to this, the nucleus and electron attraction increases as the nuclear charge is increasing across the period. Hence, the atomic radius decreases. So only the increasing nuclear charge is acting, due to which the atomic radius would decrease. So 3 marks for 3 pointers. Let's move on to question 3. The radius of most common ion of magnesium is much smaller than radius of the common ion of sulfur. Identify both ions and explain the difference in their radii. So we know that here is the electronic configuration of both magnesium ion and sulfur ion. You can see there is a one more shell in the sulfur ion, that is the third energy level shell, while magnesium only has till second energy level shells. Moving on, phosphorus is a non-metal in the third period. It reacts vigorously with excess oxygen but slowly with chlorine. Some reactions of phosphorus are shown. So you can see phosphorus reaction with chlorine and then in excess oxygen. Write an equation to represent reaction 1, the formation of compound A. Okay, so you need to remember that when oxygen is in excess, you should take P4O10. You know that 2 compounds of phosphorus with oxygen are there, P4O6 and P4O10. The things written in red color are just there to explain. You do not need to write them in the exam. So you're going to balance the equation. Now give 2 observations you could make in reaction 2. Now reaction 2 here is with chlorine. Obviously your yellowish green color of chlorine gas will disappear and the white solid PCl5 will be formed. Name compound B. Compound B here is the phosphoric 5 acid. Make sure to write this number 5. You can calculate the oxidation of phosphorus, which is 5 in H3PO4, right? Moving on, cerium is a lanthanide metal that shows similar chemical reactions to some element in the third period. Most of cerium's compounds contain Ce3+ or Ce4+ ions. Cerium shows the same structure and bonding as a typical metal. Draw a label diagram to show the structure and bonding in cerium. So you need to take care that the diagram has regular arrangement of positive ions and it is surrounded by sea of delocalized ions, as you can see in the diagram I made. Cerium oxide, 4 oxide, CEO2, is a ceramic. Suggest two physical properties of cerium 4 oxide. So a ceramic substance means any non-metallic solid which remains hard when heated. So that means it will be hard or rigid, and it will be having a high melting point. A naturally occurring sample of cerium contains only 4 isotopes. Data for 3 of the isotopes are shown in the table. The AR of the sample is given to. What you need to do is use the data given to calculate relative isotopic mass of the 4th isotope in the sample of cerium, right? And remember to give the answer in 3 decimal places, not significant figure, decimal places. So you're going to be writing the formula AR, percentage isotope A, mass of isotope A, percentage isotope. That's how you're going to put 4 of the isotopic percentage and mass, and then divide them by 100. Now, percentage abundance of 4th isotope, you can get this by just subtracting the other percentage abundances given from 100, and then you're going to get the percentage abundance of the 4th isotope. Because you can't, if you're not going to find this out, you will have 2 unknown variables in these equation that you're going to find. So it will become almost impossible for you to find those 2 unknown variables. So you need to find percentage abundance of 4th isotope and then put it to find the isotopic mass of the 4th isotope. Then you can see I have done that. I put all the relative isotopic mass and percentage abundances, and here you can see I have put the part C. Hydrogen chloride undergoes a reversible reaction with oxygen. The reaction is carried out at 400 degrees Celsius in the presence of copper to chloride catalyst. Use the data in the table to calculate the overall enthalpy change of the reaction. So the equation has been given to us. You can use this equation to make this sort of diagram to help you in your equation of finding out enthalpy change of reaction. So we know that enthalpy change of formation is what? Is when 1 mole of a compound is formed from its element under standard conditions. Now what I've done here is I have written the same equation as given here, and then I wrote all the elements that are required to make these two. It's because enthalpy change of formation of HCl and water has been given to us, so we are only going to take elements of HCl and water, right? So H2, Cl2 plus O2, and then I've made these arrows to indicate that these are indicating the enthalpy change of formations. So now helping you in coming up with an equation, you can draw a circle and mark the clockwise direction on it, and then see which 2 arrows, this equation's arrows and this arrow, are coinciding. They are going in the same direction, while this arrow and this arrow, they are going anti-parallel to each other. They are not going in the same direction, they're going in opposite direction, while this arrow and this arrow are going in the same direction. So you write all the given information that are going in the same direction as this circle on one side of the equation, and then you write all the things that are going anti-parallel according to this arrow circle, you write on the other side of the equation. Just how I've done here, we will be taking this on the other side of the equation and this on the other side of the equation. So here I've done that, and I've got the answer, negative 116. Make sure you write the sign because you won't get a mark if you won't. State the type of catalyst used in this reaction. Explain how a catalyst is able to increase the rate of a chemical reaction. First of all, you need to know if it is a heterogeneous catalyst or a homogeneous catalyst. Here the catalyst is heterogeneous. Why is it heterogeneous? Because catalyst in a different state, solid. Here copper to chloride is a solid, while all the compounds you see here, actually not compounds, all the reactants and products, they are in gaseous state. So that's how we know that it is a heterogeneous catalyst, and also that it isn't really participating in the reaction. It is only providing a surface for the reaction to occur. Now, how does a catalyst increases the rate of chemical reaction? It simply provides an alternative reaction pathway in with a lower activation energy. Pretty sure you know that. The reaction exists in dynamic equilibrium. The reaction was repeated at 1000 degrees Celsius and the same pressure. State and explain the effect on the composition of equilibrium mixture of the change in temperature. So forward reaction is exothermic. We know that from the negative enthalpy change, and increased temperature shifts the equilibrium to the left or to the reactant side and decreases the yield of the products, because increase in temperature always favors the endothermic reaction side. One thing to take note of is that to discuss both the reactants and the products, what is going to happen to reactants and products, because equilibrium mixture is mentioned here. If you are only going to write about the reactants, then you won't get a full mark. Moving on, when 1.0 mole of HCl are mixed in sealed container with 0.5 mole of oxygen at 400 degrees Celsius, 0.6 mole of chlorine, and 0.6 mole of H2O are formed. The total pressure inside the container is given. Calculate the amounts in mole of HCl and O2 in equilibrium mixture. You write the equation first that was given in the question previously here, and then you write the initial moles. Initial moles are given of HCl and O2. Obviously, initial moles of CO2 and water will be 0 because there has been no reaction. And when the reaction has taken place, equilibrium has occurred, the equilibrium moles of chlorine and water have been given to you. You can find the equilibrium moles of HCl and O2 simply by looking at the ratio. Now here, the ratio between HCl and chlorine and water is 4:2, as you can see here. So what you're going to do, you are going to simply multiply the given ratio, given moles here by 2, as I've done, and then you're going to subtract the answer from the total moles of HCl. Here, 1.6 minus 2 into 0.6. Remember that write the ratio, it is going to become easier. And similarly, you're going to see the ratio between oxygen and chlorine and water, which is 1:2, and then that means you're going to divide this number, which is same for both chlorine and water, and you're going to divide it by 2 and subtract the answer from the total moles of oxygen to get the equilibrium moles of oxygen. Calculate the mole fraction of Cl2 and hence the partial pressure of Cl2 in the equilibrium mixture. Mole fraction is calculated by moles upon total moles. Now here we are finding out for chlorine, so we are going to take the moles of chlorine and divide that by total moles are present in equilibrium. So here I've done that, and I've gotten 1:1/3. For partial pressure, you need to multiply mole fraction with total pressure. Total pressure is given here. You're just going to take your answer from mole fraction and multiply it by the pressure given to find out the partial pressure of chlorine. In a separate experiment, an equilibrium reaction mixture was found to contain the 4 gases at the partial pressure shown in the table. Use this information and expression given for Kp to calculate a value for Kp. State the units of Kp. You're simply going to take the values and plug it in the equation of Kp given. And after finding out the answer, you are going to find out the unit for Kp. As I've done here, P4 to the power P8. I have taken pascals per unit. You can also take atmospheric pressure. It's up to you. And then the unit is coming out to be Pascal -1. Okay, now question 3. A series of reactions starting from 1-bromobutane is shown. So you can see 1-bromobutane's reaction with HCN and KCN. This is clearly a nucleophilic substitution reaction. And then we have the product P is forming, which is reacting again to form this carboxylic acid. So this is definitely a hydrolysis of nitrile. Let's move on to the questions. Draw the displayed formula of compound P. Okay, so for display, you need to take care of all the bonds. You need to show, if you're making a nitrile, you need to show its triple bond with C and N, right? So compound P will be a nitrile because 1-bromobutane is a haloalkane that goes under a nucleophilic substitution to form a nitrile. CN substitutes the halogen, which is butane in this compound. So in the place of Br, we are going to make CN. Identify the reagents and conditions for reactions 1 and 2. Reaction 1 is hydrolysis. We know that hydrolysis takes place in a acidic or a basic medium, and we know since carboxylic acid is being formed, an acid must have been used. So we will write HCl, which is aqueous, obviously acidic medium. For reaction 2 is clearly elimination reaction. Haloalkanes go under elimination reactions to form alkenes. What happens is that halogen is removed from the carbon atom and from the adjacent carbon atom, a hydrogen atom is removed, and the double bond is made between the two carbon atoms, and hence alkene is formed. So the conditions would be concentrated NaOH and ethanol, or you can write ethanolic NaOH, but make sure to write concentrated. Draw the structure of repeat unit of polymer Q. Okay, so polymer Q is being made. Whenever you will see an alkene being transformed into a polymer, know that addition polymerization is being done, and but1-ene will form. This is but1-ene, and make sure to write this alkyl group in short form whenever you are writing addition polymer repeat unit. Moving on, complete the reaction scheme to show the mechanism of the reaction of 1-bromobutane with OH negative aqueous to produce R. Include all necessary charges, dipôles, lone pairs, and curly arrows, and the structure of R. So this here is the structure of R. What is happening in this reaction is it is hydrolysis of primary halogen. Primary halogen is the one where the halogen is attached to carbon that is attached to just one carbon, right? So this is a primary halogen, and it will be following SN2 mechanism, which means that the reaction will be taking place in one step. So let's see how it is happening. First of all, we will show the lone pair of oxygen, right? As I've shown here, 2 electrons of oxygen. What happens is this bond here between carbon and bromine, these 2 electrons will be taken by bromine through hydrolytic fission. Hydrolytic fission is the unequal distribution of electrons. Since here both of the electrons are be taken by bromine, so we will show it through a curly arrow as it is hydrolytic fission, and bromine will hence get a partial negative charge while carbon will have a partial positive charge. And now this hydroxide neutrophile with a lone pair on oxygen, it will attack this partial positive carbon, and this is the intermediate or transition state where carbon is shown with 5 bonds. But this is only an assumption, you do not need to include this. This is just to make you understand. We call this carbon a pentavalent carbon as it is forming 5 bonds, right? And this is the final structure of R, where hydroxide has taken the place of bromine, and bromine is formed with it, right? But1-ene reacts with steam as shown to form a mixture of 2 structural isomers S and T. You can see S is the major product, T is the minor product. Okay, so S can be oxidized with acidified potassium dichromate to form compound U. S and U both react with alkaline aqueous iodine. Identify the type of reaction that occurs when but1-ene reacts with steam. So but1-ene reacts with steam, that is a electrophilic addition, because the carbocation is formed, and anything with a positive charge acts as a electrophile, and addition due to the double bond present here, that's why addition can take place. State what can be deduced about the structure of S from its reaction with alkaline aqueous iodine. So we know that anything a ketone attached with a methyl group or a secondary alcohol attached with a methyl group will give a positive iodoform test, right? You need to memorize which compounds are going to give a positive aqueous iodine test in the iodoform test. So S has a methyl group attached to CHOH, meaning S is a secondary alcohol. Secondary alcohol is an alcohol in which the alcohol functional group is attached to the carbon, and that carbon is attached to 2 other carbons. I have drawn the structure of S here, though you don't need to draw it in because none of the questions is asking you to right now, but to make you understand, this is the alcohol functional group, it is attached to the carbon, and this carbon is attached to 2 other carbons, hence making it secondary alcohol. Explain why S is the major product of reaction of but1-ene with steam. So basically, due to positive induction effect of more alkyl groups. We know that alkyl groups are electron donating groups. They push the electrons toward the C bonded to alcohol functional group bond, and hence due to this positive inductive effect, the carbocation that is formed is more stable, right? Hence secondary carbocations, because they have more alkyl groups, will be more stable than primary carbocation. Okay, so draw the scatter formula of S, T, and U. So we know that S is butanol 2 and T is butanol 1, while U is a ketone, which is butanone, or butanone too, right? Now, write an equation to represent the oxidation of S to U by acidified potassium dicarbonate. You should use this to represent the oxidizing agent. So we know that oxidation of secondary alcohol gives a ketone, right? We know that. So here we have seen, meaning this oxidation of S will give you oxidation of secondary alcohol will give a ketone with a functional group C double bond O. So we are going to write the equation. You can write this is CH3, this is CHOH, CH2, CH3, like this, and then an oxidizing agent, and then we're going to write U compound, which is CH3, C double bond O. You are not going to show the double bond, you're just going to write CO, and CH2, CH3. Plus, don't forget to write water. Pentanoic acid is a colorless liquid with an unpleasant odor. It reacts with methanol in the presence of an acid catalyst to produce an organic product which has a pleasant fruity smell. Whenever you see a pleasant fruity smell, know that they are talking about an ester, right? Now you have to name V. So the first will come from the alcohol, which is methanol, so it will become methyl, right? And then the last name would come from carboxylic acid, which is pentanoic acid, so pentanoid. Student analyzed pentanoic acid, methanol, and V using infrared spectroscopy. The spectra were returned to the students without labels, right? Identify which of the infrared spectra X, Y, or Z corresponds to V. So we have to find out using these infrared spectrums given to us. So let's see. First of all, know what you're looking for. You know that V is an ester, right? An ester will be having an ester functional group, right? This is an ester functional group. So now you look at the table, you look at for an ester here, the numbers range that is given is this, right? So now you look at all the data given here. Is it 710 to 1750? 1710 to 1750 here. Yes, you can say, but let's look at all of them. Here, there is no absorption range of 1710 to 1750, so this is definitely not the answer. Let's look at Z and compare between X and Z, which one is better. So here, there is a peak at 710 and 750. So I think Z is more nearer than X. So answer would definitely be X. Making a line with this will help you a lot. So this is coinciding with 1710 to 1750 more. So I'm gonna go with X spectrum X for V. So I have written here X spectrum X. Now explain your answer with reference to relevant features of the three spectra in the region above 1500 centimeter per centimeter. So X and Z show a C double bond O stretch at 1730. As you can see, for X, 1730 is this, right? There's a stretch. So we know that at 1730, here you can see C double bond O. 1730 is coming in this range, which is for esters. So here there is a peak at 1730, and here as well there is a peak at 1730. So 1730 here and 1730 here. So this shows us that C double bond O functional group is